Highway bridge expansion joints are installed at movable end of bridge superstructure, expansion device at bridge deck fracture joints. The function of installing expansion device is to ensure the superstructure under temperature changes, concrete shrinkage, creep, and loading, enable displacement at that location, no additional internal forces are generated, and ensures smooth traffic flow. In this lesson, let us learn about expansion device test and inspection together. First, we will learn the classification of expansion devices. Expansion devices differ by expansion body structure. It can be divided into modular expansion devices, cone plate expansion device, rubber expansion joint, class for special shaped plate expansion device. Modular expansion devices are currently widely used for bridge expansion joints. The following mainly introduces test methods for modular expansion devices. The following table 1-to-1 is requirements for deformation performance of expansion devices. Please, during the inspection process, carefully compare and evaluate against the following standard requirements. Next, we will study the test method for modular expansion devices. Test items for tension compression deformation performance of modular expansion devices include maximum horizontal frictional resistance during tension and compression, deformation uniformity during tension or compression, maximum vertical deformation deviation per unit during tension or compression, etc. First, pre-test preparations. Before the test, place specimens directly at standard temperature 23 degrees Celsius plus or minus 5 degrees Celsius. Stand still for 24 hours. Ensure uniform temperature inside and outside the specimen. The environment must not contain corrosive gases or vibration sources affecting detection. Second, test method for tensile compressive deformation performance of modular expansion joints. First, maximum horizontal friction resistance test during tension and compression. 1. Sample placement. Effectively fix the fully assembled expansion device specimen on the test platform. Second, pre-loading. Perform graded reciprocating preloading tension or compression once on the placed sample. Third, formal loading. When stretching sample to position of maximum expansion, begin grading. Displacement control, such as plus or minus 80 mm, plus or minus 160 mm. Loading. Until loading to the position of maximum expansion constitutes one cycle. Repeat the test 3 times. Fourth, measure frictional resistance after each loading stage. Fifth, test results. Test results take the arithmetic mean of 3 cycles. When measuring horizontal friction resistance of expansion device, the frictional resistance of the test platform frame itself should be deducted. Second, displacement uniformity test during tension and compression. 1. Sample placement. Fully assembled expansion device specimen, effectively fixed on the test platform. Second, pre-loading. Perform graded reciprocating preloading tension or compression once on the placed sample. Third, mark gauge lines at both ends and middle of the specimen. Then stretch the specimen to the position of maximum expansion. Precisely measure total width at marked lines, and initial values of each gap width should be recorded. Fourth, then proceed with grading. Control by displacement such as plus or minus 80 mm, plus or minus 160 mm. Loading. Until loading to the position of maximum expansion constitutes one cycle. Repeat the test 3 times. Fifth, Measure displacement uniformity after each loading level. Sixth, test results. Test results take the arithmetic mean of 3 cycles. Third, maximum vertical deviation or deformation test during tension and compression. 1. Sample placement. Effectively fix the fully assembled expansion device specimen on the test platform. Second, preloading. Perform graded reciprocating preloading tension or compression once on the place sample. Third, formal loading. When grading loading of expansion device, select any position. At the same cross-section, measure the vertical deviation between side beams and center beams of expansion device. Repeat the test 3 times. For test results take the arithmetic mean of 3 cycles. In the end, we learn the evaluation of deformation performance test results. Expansion device tension compression deformation performance test. All items meeting the requirements of Table 1-to-1 are qualified. If any item in the inspection fails, then double the number of samples should be randomly selected from the batch. Conduct re-inspection on unqualified items. If any item still fails, then the batch shall be judged as unqualified. In this lesson, we mainly studied: first, classification of bridge expansion devices. Second, content and methods for test detection of deformation performance of modular expansion devices. Through the learning in this lesson, not only learn theoretical knowledge, greater emphasis should be placed on practice. As a member of bridge engineering detection technology, we should maintain a conscientious, responsible, and dedicated work attitude. Rigorous, practical, meticulous work ethic, and the craftsman's spirit of continuous improvement. Realize personal value in the national strategy of building a strong transportation country. After class, please consider the following questions. First, classification of bridge expansion devices. Second, whether anti-seepage test is conducted for bridge expansion joints. Third, whether bridge expansion devices undergo bearing capacity tests. Fourth, other test items for modular expansion devices besides tension compression deformation performance. Fifth, similarities and differences in test and detection methods of modular telescopic device, cone plate telescopic device, rubber telescopic device, and non-standard plate type expansion joint.